Hello. So we are doing Algebra 2, Chapter 6.1, Exponential Growth and Decay Functions. So this is a basic exponential function can be given with this equation y is equal to a b raised to power x, and a cannot be equal to 0 and b is the base. It is any positive real number except 1. So it's an exponential growth function if a is greater than 0 and b is greater than 1. So if b is greater than 1, for example, we can say a is 1 and b is 2. So we can see that with every x, this function y increases exponentially. So this is a exponential growth function. Okay. When b is greater than 1 and a is greater than 0. We can see with the example, with the graph, how it will grow. So we see this is a graph of exponential growth function, and if we put a is equal to 1, the graph would be like this. And when x is 0, so it will be y is equal to b raised to power 0 and it will be 1. So this is the point here. This is coordinate 0, 1. At the same time, if we put x is equal to 1, so it will become y is equal to b raised to power 1, which is b. So this is the coordinate where it is x is 1 and y is b. And we see that the graph rises from left to right like this. Okay. And the x-axis is this is the x-axis. So this is the asymptote. So asymptote basically is a line or a curve that graph gets very close to but never meets it or it never touches it. So x-axis is the or y is equal to 0, or x-axis we can say it is the asymptote. Okay, line y is equal to 0 or x-axis is asymptote. So in this, the domain is all real values and range is y is greater than 0. So for this function y is equal to bx, b is domain is all real numbers and y is greater than 0. If a is negative or something, then it may differ. Okay, but this is the case. Okay, so mm, let's see another concept. So this is a exponential decay function when a is greater than 0, but b is between 0 and 1, and b is a decay factor. We can understand like this: if the function is like, if a function is like b is half x. So we know with every x, like when x is 1, it is half. When x is 2, it will become 1 by 4. Then it will become 1 by 8 when x is 3. So we see that it is y gets lower and lower, smaller and smaller. So if we graph, b is will be the decay factor here, but if we graph, our function will be like this. So asymptote will still be the x-axis. Okay, but the graph falls from left to right now. Okay, so now also if we put a is equal to 1, okay, and so function becomes y is equal to bx, And if x is 0, y is b raised to power 0, and it becomes 1. So this is here, it will be 0, 1. Okay. And at the same time, if we put in this y is equal to bx, if we put x is equal to 1, so y becomes b raised to power 1 b. So it will be, so these values will be still same. This will give us 1b. Okay. But this function will decrease. Okay. So as x increases, this function keeps on decreasing. Still, x-axis is the mm, x-axis is the asymptote, and domain is all real numbers, and range is y is greater than 0. So this is fx, or we can say y is equal to bx. Okay, and b is greater than 0 but less than 1. Okay. So this is a function given, and we have to see if it is decay or growth and graph it. So if we compare it with this, we see that a is equal to 1 and b is greater than 0 and less than 1. It means it is decay. Okay. Now we have to graph this. So we can make a table of values of x and y. I'll add a minimum values in this. We have to just see the shape of the graph. So we know that b is less than 1, means with every increase, as x increases, this will become less. The value of y is will be less, and we can see from graph also. So if we graph here, it's not the exact graph, I'm just showing the values just to show that how it decreases. So this is x-axis and this is y-axis. This is 0, 1, -2, and 1 and so we see at -2 it was around 3. This was 3, so it was 2.77. Then it became 1.66, around half here. Okay. And when at 0 it was 1, and at 1 it is 0.6, and then 0.36. So we see that this graph is decreases as x increases, because the factor or the base was less than 1 and greater. It was positive but less than 1. So this shows us that this was a exponential decay. Okay, let's do one more problem like this. So this is a question given y is equal to 1.8x. We have to find whether it's growth or decay, and then we have to graph it. So a is equal to 1 and b, we see that it is greater than 1. So it will be a exponential growth. Now let's graph this. So we'll make a table. So we see that as it is a growth, exponential growth, when with x increasing, y also increases. So let's graph this. This is -1, 0, 1, 2, and 3. So I'm just approximately I'm graphing this. So this is 0.55, a point here. Okay, I'll draw it with a different color. With 0, it is 1. With 1, it is 2. And with 1, it is 1.8. So 2, it is 3.24. And with 3, it is 5.83. So we see that it is approximately. Okay, so we see that this, as x increases, value of y increases. And again, it as negative x means it is going towards negative infinity. Value approaches 0, though it doesn't touch, but it approaches 0. So this is a exponential growth function. With x increase, the value of y also increases. So we see in real life some quantities increase and decrease by a fixed percentage every year. Suppose if we buy a car, then every year its price will depreciate. Okay, but if we buy a precious metal or something, its price increases every year normally. So we can say that there is an exponential growth model and exponential decay model. Okay, so growth model can be written as y is equal to a, which was the first value, the previous, and 1 plus r. So raised to power t. T is the time. Okay, and is the initial amount, and R is the percentage increase or decrease. Or decay, we can say A is equal to 1 minus R, because 1 is like the initial amount and it decreases by R, which is the percentage uh, decrease. Okay. And this is after T years. So, and we see that R, we always write its percentage decrease or increase in decimals. T is after how many years, so it is given in years. So this is growth model and this is decay model. So let's do some problems. So in this, value of bike in dollars is given by this equation. Y is 200 times 0.75 raised to power t, and t is the number of years since bike was purchased. And so does the model represents exponential growth or decay? So because 0.75 is less than 1, greater than 0, so it is decay. So as we purchase the bike, after every year, there will be the uh, price will decrease. Okay. When t is equal to 1 or when t is equal to 0, then it was 0.75 raised to power 0. So the bike was $200. Okay. And as t is equal to 1, then 0.75 times 200, and like that it keeps on decreasing. For in the first year it decreases like it is like 0.75 times 200. When t is equal to 1, it will be 200 times 0.75, means 3/4. So what is the annual percentage increase or decrease? So as we see from here, we did this. So it is a decay model. So we will use this. Okay. So it will be B part. We will write y is equal to 200.75 t. Okay. So this will give, if we match with that, it will be 1 minus 0.25 t. So if we match with this will be R. R is percentage decrease or increase in decimals. So this is 25. So it will be 25% decrease. We can see it another way also. We see when it was first purchased, it was 200. And after 1 year, it is 0.75 into 200 means now the price is 75% of what it was. It means there is 25% decrease each year. Okay, so in the formula, we'll just write use because it is a decay. We will use this form and we will get that R is this. Okay, now in the C portion, they are asking us to uh, when it will be $50 because it was $200 in the beginning and it keeps on decreasing. So when it will be $50. So we'll again use this equation like it was given y is equal to 200.75 t. So we can use the graphing calculator also, and this is the equation, and we have to find when this bike would cost 50. So y would be 50 because y was the price of the bike, and this is 200, and this is 0.75 t. Okay, so first we'll solve this. So this will give us 0.25, 50 over 200, which is 0.25, okay, is equal to 0.75 t. So we can use a graphing calculator to solve this. 0.25 is equal to 0.75 t. But I'll use logs, and log may not be taught to you at this time, but I'll just give you a brief idea of this. So this will give us, this will be log 0.25 and log 0.75 t. Okay, so which gives t log 0.75, and this gives log 0.25. Okay, so t will be, now we can directly put the values in the calculator. So this will be 0.25 over log of 0.75. So this is gives approximately 4.81. So after 4.8 years, it would be, the value will be 50. Okay. Value of the bike will be 50 after approximately 4.8 years. Let's do some more problems. So this is a function given to us, and we have to rewrite in these one of these forms, see, and find if it is exponential decay or growth, and what is the decay and growth. So what we'll do is a is like this. Now we want the t, it the function to be raised to the power t. So we'll solve in internal like this, raised to power t. Okay, or we can write it a and 2 raised to power 1 by 3 raised to power t. Okay, So if we see 2 raised to power 1 by 3, it is 1.26 and raised to power t. Okay. So now 1.26, we know it is 1.26 is greater than 1. Okay. So we can write 1 plus r. So we can write 1 plus 0.26. So it is greater than 1. So definitely it is a growth. And R gives percentage. This R is 0.26. So that gives us, or 26%. That gives us growth or decay rate. So growth rate is 26%. So this is a function given, and we have to find whether it is a growth rate or decrease, and what will be the rate here. So what we do is, so this is, again, we'll do the way we did the last one. It is 0.5 raised to power 1 by 12. Okay. And this is raised to power t. We'll take it because we have to match here this 1 plus minus r raised to power t. So we now we have to find t raised to power 1 by 12, sorry, 0.5 raised to power 1 by 12. So this gives 0.94 raised to power t. So if we match with a, b, x, okay, we see that b is less than 1. Okay, but we'll do in this form 1 minus, it will be 1 minus 0.06 t. So we see that it matches the decay model here, this one. Okay, it matches this decay model. So what we'll do is, so this gives us, so here we can see that R is, so first thing is it is less than, it less than 1. Okay, so it is decay. And another thing is, it is, the R is 0.06, or we can say 6 percentage. Okay, so it is a decay rate, it is a decay, and the rate is 6 percentage. Okay, or 0.06. So now we considering that there is an initial amount principal like $100 or principal amount. We deposit it in an account and it pays interest R as an annual rate. Okay, it is expressed in decimals and it is compounded n times per year. So the amount of after t years will be A. So we put the amount, principal amount, some amount in a bank or like that, and the at a rate of R, and it is compounded n times per year. So A will be the amount we get after t years. So for this, the formula here given is 1 plus R by N and N T. Okay. So we'll do the related problems and then it'll be more clear. So compounding basically means in simple interest, we see that in 5 years, okay, this is the interest and we simply multiply. Compounding n times years per year means it is the interest earned both on original and the accumulated interest. Like after 6 months, the amount might have increased. So now we'll again get the interest on the increased amount. Okay, so it is the interest on interest. When interest earned on investment or saving account is added to the principal. So the future interest is calculated on a new total balance where interest is already added to it. Okay, so compounding n times per year means that we are adding the interest that time and now we have a new principal. So let's do some questions. So in this question 41, we have to find the amount which we will get. Principal amount is 3500 and time is 6 years and it is compounded quarterly, means 4 times a year. Okay. So after each quarter, the interest is added and we have now a new principal. Okay, so we'll use this formula. So this is P is 35001. And remember, we have to put R in decimals. So it will be 0.0216. Okay, and it is 4 times. So 4 times here. And this is NT, means 4. N is 4 because it is compounded quarterly, means 4 times a year, and T is 6. Okay, so we'll put 6 here. Okay, and this is simple. We can put it in calculator and then what we'll get is 3982.92. Okay, so when the interest rate is 21.6%, it is compounded quarterly, means 4 times a year, and time is 6. So now the total amount we get up when we deposited like $3,500, but after 6 years, when the interest was 21.6 and it was compounded quarterly 4 times a year, the amount after 6 years we will get is 3,982. Okay, let's do one more problem. So here the interest rate has changed and we are compounding monthly. Monthly n means number of times a year. So n is now 12. Okay, so everything else is 3500. Again, we have to put this in decimals, so it was 0.0229 and instead of 4 we put 12 and we put 12 and again it is after 6 years. Okay, so now we put, so remember compounded monthly means how many times in year, n means in a year. Okay, and this we have to always put it in decimal. So if we put this in calculator and we will get it as 4014.98. So because we were compounding monthly, every month we were adding interest and now the interest was applied on a new principal. So we are getting more. Also, though the interest rate was also different. So let's do question 43. Now, one more. So in this, the last one which we saw, we got 4 0.00114.98. Now in this case, it is compounded daily. Daily means n is, considering there are 365 days, so n is 365. Okay, so let's find A, which was 3500. Interest rate has changed now. It is less rate, interest rate, but compounded daily. So we'll see whether we get more amount, or so it is point, we again put it in decimal, 365, and n is 365, n is this, and years is still 6. Okay, so when we put this in calculator, what we are getting is 3906.18. So now we are getting less than this because this was compounded monthly, this is daily, but the interest rate has decreased. Okay. So please do each problem in this exercise, and please let me know if you have any difficulty. Thanks for joining, and please continue practicing.